Hey everyone, welcome. Every now and then, a story comes along that feels like a classic underdog movie. And today, that's exactly what we're looking at, but from the world of AI. We're talking about a small, super nimble AI model that's basically stepping into the ring and landing some major punches on the industry giants. So, for what feels like forever, the big race in AI has just been about one thing: scale, right? More data, way more computing power, and building these absolutely massive models with billions, sometimes even trillions of parameters. But does it have to be that way? Is bigger always better? Is that really the only way for AI to get smarter? And just look at this comparison. The difference in scale is, well, it's just staggering. On one side, you've got this little model with just 2.6 billion parameters. And on the other, a monster with over 260 billion. I mean, it's the perfect David versus Goliath setup. So the big question is, how on earth did David even stand a chance, let alone win? Okay, so let's set the scene. Our story really kicks off on Christmas Day, of all days. An AI startup called Liquid AI drops this surprise gift on the developer community. It's an experimental new model, and believe me, it immediately started making some serious waves. So here it is, our contender, LFM2 2.6b exp. Now, at its heart, it's what you'd call a small model, just 2.6 billion parameters. But here's the really crucial part. This thing was built from the ground up to run super efficiently on the devices you and I use every single day. We're talking about smartphones, laptops, not these giant power-guzzling data centers. All right, so how does a model this tiny actually manage to compete with the big dogs? Well, the secret sauce really comes down to two things: a really clever training method and a super innovative architecture. Let's dive into what makes them so special. First up, let's talk about how it was trained. So instead of the usual approach, where you spoon-feed a model tons of examples, this one learned using something called pure reinforcement learning. A great way to think about it is like a character in a video game that just learns to win by trying, failing, and slowly getting better and better. It's a way more efficient way to learn, and it means it doesn't need some huge teacher model holding its hand. Okay, so the second piece of this magic puzzle is its architecture, which is a hybrid. It does this really clever thing where it switches between two different techniques. First, it uses a method called grouped query attention, or GQA for short, to basically understand the context of what's going on. And then it mixes in these things called convolutional layers. It's this combo that's like the secret recipe for making it so ridiculously fast and efficient. All right, so we've looked under the hood, we've seen the strategy. Now it's time for the main event. Let's get to the numbers. How did this little model actually do when it went head-to-head with the industry's biggest players? And wow, the results are just stunning. Take a look at this. On the instruction following benchmark fbench, our little 2.6 billion parameter model doesn't just compete with DeepSeek's massive model, a model that's 263 times bigger. It flat out beats it significantly. I mean, this is a huge deal. And the wins just keep on coming. Next up is mathematical reasoning, which, as you know, is a notoriously tough nut for AI to crack. Well, LFM scores over 82%. That's better than other well-known models in its size class like Llama and Gemma. So yeah, this thing is definitely not a one-trick pony. Seriously, it just keeps getting better. On a test called IFEval, which is all about how well an AI can follow really complex multi-step instructions, LFM2 scores an absolutely incredible 88%. That is good enough to beat a whole bunch of models that are way bigger, over 10 billion parameters. It's not just about raw power. This model is incredibly precise. Now hold on, this number, 42%, might not seem massive at first glance. But you have to understand what it represents. This is from the GPQA benchmark, which is basically full of graduate-level, PhD-style questions. Getting a score of 42% on that for a model this small is, well, it's pretty much unheard of. It shows a level of reasoning that is just way, way beyond its weight class. And this really brings us to a phrase that just perfectly captures what's happening here: PhD-level reasoning on a smartphone. I mean, just think about that. The ability to have that kind of complex, expert-level thinking, not coming from some massive supercomputer, but from the device you hold in your hand. That's not just an upgrade, that's a genuine game changer. Okay, so this is obviously a huge technical achievement, but so what? What does it actually mean for us, for regular users? Why should we care about having PhD-level reasoning on a smartphone? Let's connect these dots. Well, because this tech is made to run locally, right on your device, it can start to automate all those little things that are woven into our daily lives. I'm talking about things like handling customer support chats instantly, or finally getting your email inbox under control, or getting a perfect summary of a 2-hour meeting just seconds after it ends. And all of that happens right there on your phone or laptop. And when you run AI locally like this, you get three massive benefits. First, and this is a big one, privacy. Your personal data never has to leave your device to be sent to some random server in the cloud. Second, it's way cheaper. No more paying for ongoing server costs. And third, it's fast, like really fast. The responses are pretty much instant because there's no lag from the network. And you know what the best part is? Liquid AI didn't just build this amazing thing and then lock it up. Nope. It's completely open source. The model is available right now on Hugging Face. That means any developer out there can download it, play with it, and start building the next wave of super powerful, super private AI that runs right on our devices. So this brings us full circle, right back to that question we started with. But now we have a totally new perspective. The success of a model like LFM2 proves without a doubt that in the world of AI, intelligence isn't just about size. It shows that with smart design and efficient training, small can be incredibly mighty. And that leaves us with a really fascinating thought to chew on. Are we witnessing the beginning of the end for the era of giant cloud-based AI? I guess only time will tell. Thanks for joining me.